Okay, so today we'll be learning about inverse trig functions. So for every function has an inverse function, only if the y value can match with only one x value. So if that y value doesn't have an x value, sorry, but it can't be a trig function. This is because the sine function fails at the horizontal line test. It's not a one-to-one, so it can't exist. Let's begin with an example here. Sine square root 3 over 2. Pretty simple, right? First, we do the degree. We need a unit circle first, but I have one, luckily. So we know sine is always going to mean y value. And we already have the value right here. So we look on our handy little unit circle right here. We look for the y value. So, right here. But wait. There is two possible y values. We can have this one or this one. How do we know which one it is? Well, for sine, it is always going to be on this side of the unit circle. So it could only be this one right here, that y value. So if you look at the y value, we see it as a square root of 3. All right, next one. Cos. Same thing as sine, but it's the x. But there's two. Remember, there's two. This one, it's only the upper half that we use to find it. So that means it can only be this one because this is the x one. 3 pi over 4. That would be our answer. Our tangent is where things get a little different. Basically the same thing, but it's going to be y over x, right? So you're gonna have to do a little bit of math on this one. And this, is probably, there's gonna be 2 like usual, but we use this half like sine. So let's see, we have to find the negative square root 3 over 3. Easy. Already have an example right here. So we know it can't be this because it doesn't equal square root 3 over 3. Is it's not right? But if we do 1/2 over square root 3 over 2, and we do that math, we get square root 3 over 3, which is, if you look on that, you just have to find that one. It's right over here, and that gives us the correct answer. Now some practice problem. All right, first practice problem. So we know it's sine, correct? So what does that mean? First we have to look negatives. Okay, sine, whatever, sorry. Negative 1/2. All right, we have to look at, and we know it's y. So look at the unit circle. The y value is to be negative 1/2. So it can't be that one. Oh, it could be xy. No, it can't be that one. And negative. Okay, it can be that one. Let's see, negative. Oh, right here. It could be this one. Or it could be this one. But how do we know? It only has to be on this side, so it has to be this one. So the answer would be 11 pi over 6. Perfect. Next, we have cosine. So now that is the x, so we go, okay. 1/2. Positive 1/2 x, right there. And there's gonna be another one right here. But which one do we use? We know it's the top half, so it has to be this one. So the answer would be square root over 3. Next up is tangent. This one we're gonna have to use a little bit more math on. So for this one, we kind of have a trial and error type thing. So kind of guess, what do we think it could be? Okay, I think it's gonna be square root 3 over 2 over 1/2, right? That's what I think. But you do the math, you only get square root 3. But that is not this, so we can't use that, obviously. Okay, let's try it the other way. Let's try 1/2 root 3 over 2. Wait a second. That's perfect. Now, we know that because we have to use it's the same as sine, so we have to use this half, right? But we have to go backwards because it's negative. So it goes back 1. It's not this one. It's going to have to be this one. So that would be negative pi over 6. Those are my example questions. Yep. All right. This is how we describe a distribution using SOCV or SOCVS, some say. So S stands for shape, so the shape of the function you're doing or whatever. O is outlier, so anything that's out of place or doesn't belong. C is center, so where the center would be of the graph or whatever you're using. And V, variability, which is basically just the range, so the lowest minus the highest. When describing the shape of a distribution, use ly adverbs, right? Because you're never certain on these, usually. 99% of the time, it's not 100% you're sure. So use like fairly symmetric or slightly skewed to the right, right here, This would be the example of a dual one, but as you can see here, this is skewed slightly to the right, obviously, because it's mostly towards the right here. The outlier, we have a big outlier right here. You see that guy all the way by himself, so he would be considered the outlier. The center, this is easy. You just find the mean or the median, or you can just count. Use a basic way to find the center. Easy. The range, the 12 and the 81 are the lowest minus the highest. And obviously you need some context. Usually context is just kind of putting in your own words everything that you find. So the distribution cost for textbooks is slightly skewed to the right. Use that right there. With a potential outlier of 81. Potential, we're not 100% sure, we never know. And the mean is 285, and the range of the data is 690. Basically just rewriting what we have here into sentences, That's all it is, basically. Let's do some examples. All right, example time, or practice time. The sizes in a square feet of 20 rooms in a student-resident hall at a certain university are summarized in the following histogram. So I kind of already did SOCV here, SOCV, we already did that. So now we do S, shape. Honestly, this shape is a bit odd, honestly. You don't see this very often, but I would say, let's say evenly, have the ly, distributed. Yeah, I would say evenly distributed, because it's kind of like even, basically. That's fine. Oh, outlier. I wouldn't say there would be an outlier on here. It seems pretty even, so I would do none. No outlier. Center, I would say this would be the center, so it'd be like 1. Yeah, I'd say like 1 would be the center. Or sorry, not 1. 200 to 250. That little would be the center. Is that center? Now get the highest minus the lowest. So 100 minus what is that? 75. That'd be 60. All right. Now I want to show you how to write the word form, because that's kind of depends on the person. But all you have to do really is to incorporate every one of these. So it's the graph above is evenly distributed. There's no outliers. The center is around 200 to 250, and the range is 650. That's basically it. It's different for everyone. It's just explaining it, stuff like that. Yeah, that's basically it.